My dear students, in my previous video, we have solved some problems in the topic integration by using the method of partial fractions. So in this video also, I am going to continue the integration problems by the method of partial fractions. This method is, you can find this method in State Board and CBSE syllabus. This topic is in 12th standard, CBSE syllabus, it is in 12th standard, and the same topic is in 11th standard in the State Board syllabus. Therefore, these videos are very important for State Board 11th standard students as well as CBSE 12th standard students. So both set of students follow these videos and you can solve the problems by using these videos. Okay. Already we have solved 3 types in the method of partial fractions. We have solved 3 types. Then 4th type is of the form integral px square plus qx plus r divided by x minus a into x square plus bx plus c dx. See, first type is simple. The denominator factors are just linear factors, and the second one is multiple factor. Denominator factors are multiple factors, and the third one is the denominator factor if it is linear and a factor which is factorizable, another factor. So those are the 3 types you have seen already. Now type 4 is the denominator is in the linear factor into a quadratic factor which is not factorizable. So in the previous type, the denominator factors are linear and quadratic, but the quadratic factor can be factorizable. That is method 3. But in this type, the denominator factor, quadratic factor, cannot be factorizable. So this type can be split into a by x minus a. The a by the linear factor x minus a plus, since the another factor is not factorizable, even though it is a quadratic factor, it is plus bx plus c by x square plus bx plus c. So second factor, quadratic factor, which is not factorizable, that can be split as bx plus c by x square plus bx plus c into b. So this is type 4 problem, and you consider an example. Evaluate integral x square plus x plus 1 by x plus 2 into x square plus 1. So 2 factors are you can find in the denominator. One is linear and another is quadratic, but it is not factorizable. X square plus 1 cannot be a factor. The x square plus 1 cannot be factorized, even though it is a quadratic. Okay. So this is for type 4 problem. So you can consider this problem as you just x square plus x plus 1 by x plus 2 into x square plus 1. Now this can be split as the split in the type a by the linear factor x plus 2 plus bx plus c by the quadratic factor x square plus 1, which is not factorizable. So this is the form a by x plus 2 plus bx plus c by x square plus 1. Now equating the numerator x square plus x plus 1 equal to, this can be divided by x plus 2 both sides, so you can get a into x square plus 1 plus, you bring this to the numerator of that right hand side, you can get bx plus c, and x square plus 1 cancel, you will get the linear factor x plus 2. So on factory, by taking x square, x plus 2 x square plus 1 as LCM, you bring it to the right hand side, a into x plus 2 cancel, you get x square plus 1, plus bx plus c into x square plus 1 cancel, you will get x plus 2. bx plus c into x plus 2 and a into x square plus 1. By that method of What is that? LCM principle. Simple fraction method. You can find these steps. And here, using this equation, we have to find out the unknowns capital A, capital B and capital C. For that, you can first substitute x equal to minus 2. It becomes 0. If you put x equal to minus 2 plus 2 0, the entire term becomes 0. Second term is 0. You can get the value of A. Put x equal to minus 2. X equal to minus 2. Minus 2 square, 4. X is minus 2 plus 1 equal to, if you put x equal to minus 2 whole square is 4, plus x into minus 2 is minus 2 plus 1 equal to A into, x is minus 2 square is 4 plus 1 plus bx plus c, b minus 2 plus c into, if you put x equal to minus 2 plus 2, cancel, you get 0. So the second term becomes 0. You will get 5a equal to 6 plus 4 plus 1, 5 minus 2, 3. 5a equal to 3. From this you get a equal to 3 by 5. A equal to 3 by 5. Okay. Next, you can compare the coefficients of x square on both sides. Next step is, we have to compare the coefficients of x square on both sides. Okay. Now, comparing the coefficients of x square on both sides in this equation, you will get a coefficient of x square on the left hand side is 1. Comparing the coefficients of x square on both sides. Comparing the coefficients of x square on both sides, here in this expression you have to compare the coefficient of x square on both sides. Here x square coefficient is 1 on the left hand side, right hand side x square coefficient is a plus bx into x is bx square. If you multiply x with this x, you will get x square, bx square. So x square coefficient is plus b. Compare the coefficient of x square, it is 1, here a plus b. You know a is 3 by 5. So 3 by 5 plus b equal to 1. So b equal to 1. You bring this 3 by 5 to the left and say 1 minus 3 by 5, that is 2 by 5. So you get b equal to 2 by 5. You know a is 3 by 5 and b is 2 by 5. And next, substitute x equal to 0 on both sides. Next, substitute x equal to 0 on both sides. Substitute x equal to 0, 0 plus 0 plus 1. Left hand side is 0, x square is 0 square plus 0 plus 1 equal to a into 0 plus 1. It is a into 1 plus b into 0. Bx plus c, a into b into 0 plus c into x is 0, 0 plus 2 is 2. Substitute x equal to 0, 0 into b is 0, 0 plus 2 is 2, so 2c only. Here you will get 1 equal to a plus b into 0, 0 plus 2c. Already you know a equal to 3 by 5, 2c equal to 1 minus 3 by 5, that is equal to 2 by 5, sorry. 1 minus 3 by 5 is 2 by 5. So 2c equal to 2 by 5, c equal to 1 by 5. 2c equal to 2 by 5, c equal to 2 to cancel, you will get 1 by 5. So you know the values of a, b and c. Now you substitute in this integral x square plus x plus 1 by x plus 2 into x square plus 1 dx equal to integral a by x plus 2 dx plus integral bx plus c by x square plus 1 dx In this integral, we have to substitute the values of a, b and c. That is, listen. A is 3 by 5 and b is 2 by 5 and c is 1 by 5. By substituting the values here in the integral, the problem becomes left hand side integral you can get by I. You consider this problem by I. A is 3 by 5. You take that 3 by 5 outside. Integral A is 3 by 5 into 1 by x plus 2 dx. Plus what is b? B is 2 by 5. 2 by 5 plus dx plus c is 1 by 5 by x square plus 1 dx. Now you can split this into 3 by 5 into integral 1 by x plus 2 dx. Plus you can bring this 2 by 5 outside. 2 you can keep out inside the integral only. You bring this 1 by 5 only out of the integral. 1 by 5 into integral 2x by x square plus 1. You keep the 2 inside the integral only because the denominator derivative is in the numerator. Derivative of x square is 2x, which is in the numerator. So it is the form integral f dash of x by f of x dx is log of the denominator, you know, the rule. So derivative of the denominator is in the numerator. For that you keep 2 inside the integral plus integral 1 by 5 into 1 by x square plus 1 dx. So by integration you will get integral 3 by 5 integral 1 by x plus 2 is log of x plus 2. Three by 5 into 1 by x plus 2 is log of x plus 2 by rule. Log of x plus 2. This is derivative of the denominator is in the numerator, therefore this is 1 by 5 into log of the denominator, log of x square plus 1 and plus integral 1 by 5 into integral 1 by 1 plus x square is tan inverse of x. You know by formula integral 1 by 1 plus x square is tan inverse of x plus an integrating constant c. So the answer for this problem is 3 by 5 log of x plus 2 plus 1 by 5 into log of x square plus 1 plus 1 by 5 into tan inverse of x plus c. That's all. Okay. Next, after solving this problem, we are going to the next type 5. That type 5 is different from this, and the type 5 is the numerator degree of the function, numerator degree function, it should not be greater than the denominator function. See, in the problem, numerator degree is x square, denominator you know x square into x cube. The degree of the numerator is square 2 and the degree of the denominator is x square into x is x cube 3. Degree of the numerator is 2 and degree of the denominator is 3. Like that, every problem in this type, the degree of the numerator should be less than or equal to degree of the denominator. But type 5 is, if suppose the degree of the numerator is greater than or equal to the degree of the denominator, how can we solve the problem using that type 5? That we will see in the next video. Thank you.